Hello everyone. This week, we are going to learn about arrays and pointers. First, we are going to learn about arrays and pointers and how to use them, and then we are going to finish the class with an example using arrays and pointers. First, let's learn about array. Array is a set of variables of the same type. Each value constituting the array is called an element, and the number indicating the position in the array is called an index. The index always starts with 0. Arrays are the most basic data structure available when you need to deal with a lot of the same kind of data. An array can be declared as a one-dimensional array, two-dimensional array, or more multi-dimensional array, depending on the format in which it is declared. First, let's learn about the most basic arrangement, the one-dimensional arrangement. The one-dimensional arrangement is declared in the same form as the basic form. The type specifies the type of variable that enters the array element. The array name is used to access the array after the array is declared, and the length of the array specifies how many array elements it will have. At this time, the length of the array must be declared as a constant, not a variable. Also, if you declare an array and do not initialize it, each array element will contain garbage values that have no meaning. Therefore, care must be taken not to use uninitialized arrays. The example below is an example of declaring an array and initializing it. Initially, you can see that the int-type grade array of length 3 is declared, and the score is stored by accessing the grade array using index. This time, we will learn how to initialize the array simultaneously with the declaration. Like variables, arrays can be initialized simultaneously with declarations. Listing initial values using braces is called an initialization list. At this time, the type of initialization list and the type of arrangement must match. If you look at the first form, you can see that the array is declared using type, array name, array size, and immediately initialized with initialization list. If the initialization list is less than the length of the declared array, the rest of the array is filled with 0. Conversely, if the array is initialized with the initialization list without declaring the length of the array, the length of the array is automatically set to match the initialization list. Let's go into more detail through the examples. First, if you look at B and C arrays, you can see that the length of the initialization list is shorter than the length of the declared array, so the remaining parts are all filled with 0. In addition, initializing an array using an initialization list is only possible when declaring the array. Therefore, in the case of array D, an error occurs because it tries to initialize after the declaration of the array. The array A in the lower right is an example of omitting the length of the array and declaring and initializing the array. However, B array fails because it omits the length of the array without an initialization list. Let's all pay attention to the declaration and initialization of the array. If you want to copy an array or do something specific to an array element, you must know exactly how much memory that array occupies. Therefore, this time, we will learn how to find the size of the memory occupied by the array and the length of the array. First, the size of the memory occupied by the array can be obtained by multiplying the length of the array by the size of the data type of the array. Conversely, the length of the array can be obtained by dividing the size of the array by the size of the data type of the array. The grade array did not specify the length of the array at the time of declaration. Let's check how the length of the array is set when the array is initialized with the initialization list through the equation seen above. First, the memory size of the entire array can be obtained through size of grade, and the memory size of the data type of the array can be obtained through size of grade 0. In this way, it can be seen that the grade array has a length of 3 in the same way as the initialization list. Now that we have learned about one-dimensional arrays, we will go one step further and learn about multi-dimensional arrays. A multi-dimensional array means an array of 2 or more dimensions and an array with another array as an array element. In other words, a 2D array is an array with a 1D array as an array element, a 3D array is an array with a 2D array as an array element, and a 4D array is an array with a 3D array as an array element. We will learn about the simplest form of a multidimensional array, a two-dimensional array. A two-dimensional arrangement is an arrangement having a one-dimensional arrangement as an arrangement element. C does not provide a separate type representing a two-dimensional array. Instead, you can use another one-dimensional array as an array element of a one-dimensional array to represent a two-dimensional array. A two-dimensional array can be declared according to the following grammar. The declaration form is similar to a one-dimensional array, but unlike a one-dimensional array, the length of the array must be declared divided by the length of the column and the length of the row. Like a one-dimensional array, a two-dimensional array can be initialized simultaneously with the declaration. The format is as shown in the basic form below. In this case, the two-dimensional array may be initialized in various ways, and there is a method of initializing all elements of the array together first. Second, only some elements of the two-dimensional array may be initialized. As shown in the following example, only the desired array elements of the two-dimensional array can be initialized, and all non-initialized array elements are initialized to 0. Like a one-dimensional array, a two-dimensional array can automatically set the length of an array without specifying the length of the array. However, you can omit the length of the column, but you must specify the length of the row. The example shows that the length of the column is omitted, but the length of the column is finally set to 4 according to the initialization list. This time, we will learn about pointers. Before learning about pointers, you should first understand the address value of C. The address value of the data means the starting address of the memory where the data is stored. In C, these address values are expressed by dividing them into 1-byte memory space. For example, the int type variable a is actually 4-byte, but the address of a is 0x01, the first address of memory occupied by a. A pointer is a variable that stores address values in memory, also called a pointer variable. Just as a char type variable stores characters and an int type variable stores integers, a pointer stores address values. The operators used in association with the pointer are as follows. First, the address operator uses the name of a variable to return the address value of that variable. The AND symbol is read as an ampersand and is also called the bungee operator. Second, the reference operator uses the name of address of the pointer to return the value stored in the address it points to. The reference operator is used to declare the pointer. A pointer is declared using a type, reference operator, and pointer name, which is the type of variable the pointer wants to point to, and the pointer name is used to access the pointer after the pointer is declared. After declaring the pointer must be initialized before using the reference operator. Otherwise, you will change the value of the unintended memory. Therefore, the C compiler generates an error when using the reference operator for uninitialized pointers. We recommend that you initialize the pointer at the same time as the pointer's declaration as an example. This example refers to the data of the address value pointed to by the pointer along with the address value of the pointer. The first declared variable value contains 7 and is a variable with a memory address of 8000. The pointer variable p2 is a variable that contains the address 8000 of the variable value and has a memory address of 5000. The pointer value p1 is a variable that contains address 5000 of the pointer variable p1 and has a memory address of 1001. In this way, the pointer variable can point to the address of another pointer variable. The first printf in this example uses the size of operator to determine the size of the pointer variable. A pointer variable is a variable that deals with an address that represents the location of the variable in memory. So, its size is generally determined by the CPU. However, you can specify the size of these pointer variables directly when compiled by the compiler. Therefore, the size of the pointer variable can vary depending on the type of CPU and the policy of the compiler used when compiling. It also changes the pointer type according to the type of variable the pointer points to. This is because the type of pointer tells you the size of the memory to be referenced when referencing a value through a reference operator. You can also use a pointer to perform operations. However, the pointer can only perform limited operations, such as increasing or decreasing the value. Pointer operations have the following rules. Addition, multiplication, and division between pointers mean nothing, and subtraction between pointers indicates the relative distance between the two pointers. You can add or subtract integers to the pointer, but do not allow operations with real numbers. Finally, pointers can be substituted or compared. This example compares the increase in pointer operations according to type. The initial address value stored in all pointer is 0x00. However, after a pointer operation that increases 1, the address that the pointer points to depends on each pointer type. The increment is equal to the size of the type of variable the pointer points to. For example, the increase in the int type pointer is increased by 4 bytes, the size of the int type. The same applies to the subtraction of pointers. The following examples show comparison and substitution operations between pointers. Pointer num1 points to num1 and pointer num2 points to num2. Because they are different, pointer num gets value of pointer num1. It means pointer num2 points to num1. Lastly, pointer num1 and pointer num2 points to same variable num1. So far, we have looked at the concepts of arrangement and pointer. Now, let's solve the questions using the things we learned earlier and wrap up the class. This time, let's make a program that uses pointers to swap two integers. Stop the video for a moment and take plenty of time to figure it out. Did you succeed in solving the problem? This problem requires the idea of declaring additional temporary variables for swap. These temporary variables are usually named temp. Therefore, after you first receive two integers, you declare two pointer variables pointing to each of the two integers. After that, you can use the temp variable to change the address value that the pointer variable points to. Be careful about making a good distinction between using asterisk and using ampersand. This is the end of today's class. Good job. See you next time.